Newton's laws of motion. Newton's laws of motion. The things that we see every day require different forces to make it work. Let us learn the 3 laws of motion with our friends. The ball on the ground will not roll all by itself. Even the truck will stay in the place where it is placed. The ball and the truck on the ground will not move if it is not acted upon by an unbalanced force, that is, a push. The ball will not roll far on the rough grassy yard. It rolls farther on a surface that is smooth and hard. Once the ball starts moving, unless acted on by an unbalanced force of gravity and fluid friction of air, it will never stop. Objects on Earth, unlike the frictionless space about which the moon travels through, are under the influence of friction. Newton's first law of motion. An object at rest will stay at rest, and an object in motion will stay in motion at constant velocity unless acted upon by an unbalanced force. It is also called the law of inertia. Coming back to the truck, observe that the toy truck stayed where it is placed until it is pushed. Inertia of rest. The tendency of a body at rest is to remain at rest. It can also be defined as the reluctance of an object to start moving. A force is necessary to overcome a body's inertia of rest and make it move. Moving objects need a force to stop them moving, as their inertia tends to keep them moving in the same direction. The truck continues to move till it is stopped by the side track. Inertia of motion. The tendency of a uniform linear motion to continue in this state. It will be easy to pull an empty wagon than to pull it when it is full. But even a big push will not move a big car. Inertia depends on the mass of the object. The bigger the mass, the bigger the force needed to make it move. Experience has taught us that when something has more mass, it is more difficult to change its state of motion. When small force is applied on an object, the object accelerates less. It accelerates more when more force is applied. Thus, acceleration is directly proportional to the magnitude of the resultant force. When an object is acted upon by a constant force, its resulting acceleration is greater if the mass of the object is small. A large mass enhances small acceleration. Newton's second law states that when an unbalanced force acts on an object, the objects accelerate in the direction of the resultant force. The acceleration is proportional to the magnitude of the resultant force, and the force equals mass times acceleration. F is equal to ma. According to Newton, whenever objects A and B interact with each other, they exert forces upon each other. There are 2 forces resulting from this interaction. These 2 forces are called action and reaction forces. Consider the flying motion of birds. A bird flies by using its wings. The wings of a bird push the air downwards. In turn, the air reacts by pushing the bird upwards. The size of the force on the air equals the size of the force on the bird. The direction of the force on the air, downwards, is opposite to the direction of the force on the bird, upwards. Action-reaction force pairs make it possible for birds to fly. Newton's third law of motion. For every action, there is an equal and opposite reaction.